Okay, so today we will discuss symmetric encryption algorithms. We already discussed in our first part definition of cryptography, difference between cryptography and steganography, and then we also discussed the types of cryptography in detail. Today we will talk about some symmetric encryption algorithms. I'll give you basic overview, basic properties, description of symmetric encryption algorithms. We'll discuss algorithms in detail in our lab. So symmetric encryption algorithms, those algorithms, if you want to give a definition. So algorithm, security algorithm, in fact, algorithm that uses same key for encryption and same key for decryption. So any algorithm which uses only one key for encryption and the same key for decryption is known as symmetric encryption algorithms. And you know what? Firstly, when cryptography was introduced, symmetric encryption was basically in place. In fact, it started all with the symmetric encryption algorithms. All you have to do is you need to make your key secret. So only this is the most classified information, secret. We can't make algorithms strong. Like anybody may know your algorithms, but key is something that we really have to protect. There are many different symmetric algorithms are available. One of the algorithm is DES. Second algorithm was triple DES. The third AES, which we still use. Fourth one is the these are some European standards like CAST, IDEA, Blowfish, and some other. These are some European standard. DES, it stands for Data Encryption Standard. Encryption Standard. We will discuss simplified DES in detail in our lab. Triple DES is basically it's the extended form of DES. Then we have AES, which is Advanced Encryption Standard. Advanced Encryption Standard. So let me give you basic some properties, some like what we can achieve with symmetric encryption, what we cannot, and then I'll go in detail of DES and some other algorithms. The attributes of some attributes of symmetric encryption. So we can only get three main things with the symmetric encryption. Number one, we can ensure confidentiality. So we can ensure confidentiality. Secondly, we can provide integrity. The third thing that we can provide is availability. So these are the three things that the symmetric encryption algorithms they actually provide. They don't provide authentication, not either non-repudiation. These two are the feature of asymmetric encryption. So let's start with the DES algorithm. Let me give you an idea about DES algorithm, the key size, block size, and all that. So DES algorithm was basically it was designed back in 1970. So it was designed back in 1970, but it was unveiled in 1997. So in 1997, Department of Defense they unveiled this particular algorithm. DES was basically it's a joint venture of IBM and Department of Defense. So IBM and Department of Defense, it was they collectively work for DES, and DES is basically a simplified form of IBM's renowned algorithm Lucifer. So Lucifer was designed back in 1966. It used to be a very robust algorithm and very complex as well. DES is basically a simplified form of Lucifer. DES uses mainly the key size of DES is 56-bit, and we use two main keys in DES. So each key size is 56-bit, and it encrypts the data data block or data size was 64-bit. So at a time it uses 56-bit of key and encrypts 64-bit of the data. When DES was unveiled back in 1997, it received many attacks, many vulnerabilities were reported. So Department of Defense, they suspend this DES algorithm, and then they started using triple DES just to increase the computational complexity at the for adversaries. Triple DES is basically nothing. It's basically we just have added 3 rounds of DES. 3 rounds of DES. So 3 rounds of DES means, let's say, for example, in the first round, we have 1 DES. We use 3 main DES instead of 1 DES. So firstly, let's say this is our plain text, or you can say your original message. So firstly, plain text will be encrypted by using first DES. The output of first DES will become input of second DES. Output of second DES will become input for third DES, and the output of third DES will become over ciphertext. This was how DES, the triple DES works. Again, it was, again, because we have including more chaos, 2 keys here, 2 keys here, 2 keys here. So attacker has to actually crack all those keys. So it's like attacker has to crack 6 keys in order to decrypt the data. So again, the thing is, since DES was vulnerable, so automatically triple DES was also vulnerable against the same attack. Although attacks, like it takes more time, but eventually it is vulnerable. Next is the AES. AES was approved by NIST back in 2000. In 2000, NIST approved AES, and AES is basically algorithm. This is basically what we over US federal government. They actually use this particular algorithm for encryption of their data. For example, your social security number, the citizen information, and all that stuff is basically protected by AES. Other than that, AES, it also comes with Microsoft Windows. With Microsoft Windows, if you guys use BitLocker. So BitLocker is basically an encryptor through which you can encrypt your hard drive. So for example, your username and the password will become your key. And AES is basically algorithm that comes with Microsoft Windows. BitLocker, the application BitLocker. AES, it's basically more complex as compared to AES. The best thing about AES is the data size is 128-bit. So it takes 128-bit chunk and use minimum key size is 128-bit. 128-bit, but this is a variable key, like you can use a 256, you can use 512, etc., in order to increase the complexity. As I mentioned earlier, algorithms are known to everybody. Like everyone knows what you got, which algorithm you use. But key is something that is more precious, more secret, which we have to secure. Please remember that. It's an important question from exam point of view as well. Next, the most important thing is basically we are talking about this key. What is basically key? How we can generate key? How each time we can get the key? So there is a term which is basically becomes the second agenda item, key stream. Key stream is basically it's stream of bits, like it's the stream of bits having following properties. Following properties. Number 1. It should be like attacker should not or cannot predict it, because if your key gets compromised, all the symmetric encryption will be on stake. Everything will be compromised. Secondly, attacker cannot predict that. Secondly, both legitimate parties like sender and receiver should have copy of secret key of this key stream or secret key. or they should have a mechanism to generate identical keys, same keys in fact. And again, for each session we use a different private key, because if you use if there is any static behavior, staticness in your environment, it is vulnerable. So to generate a key, there are many phenomena that we use to generate the same key on the sender and receiver end. For example, one of the ways using PRNG, pseudo random number generators. Pseudo random number generators. Like we can use some pseudo random number generator in order to generate keys. Examples are there are many examples. One is LCG, linear congruential generator. Another is LFSR, linear feedback shift register. We'll talk about it in detail. There are many other as well, like for example Kasami sequence, gold sequence, etc, etc. Other than that, we can also use OTP. OTP stands for one-time pad. One-time pad, like one password at a time. This is basically another scheme. You can distribute this one-time password or one-time pad by using different electronic ways as well. Number 3 is hash function based keys. Hash function based keys. These are the 3 main models how we can generate key streams. Numbers. Let me just give you a basic idea about pseudo random number based scheme. In fact, the first one, PRNG. In the pseudo random number, let me give you example of LCG, linear congruential. So LCG, we will discuss LFSR in detail in our lab. So LCG is basically it use an equation. Let's say equation is xi plus 1 equal to a xi plus c mod m. So this is the equation to generate both sender and receiver. They have this particular generator. So a is basically a multiplier, while c is it's called increment. M is just for modulus, just to put a limit. I believe everybody is well familiar how to calculate a modulus. If not, then it's very simple to understand it. Let's say, for example, if you want to calculate a mod for 10 mod 20. So 20 is basically a limit. The number on your left side cannot be bigger than the number on the right side. If it goes, bigger than that, what's going to happen? We will divide and the answer is going to be remainder. So let's say 10 mod 20, because 10 is less than 20, so answer is 10. For example, if it would be 21 mod 20. So now 21 is greater than 20. So now what we will do is we will divide 21 with 20 and divide it, and answer is going to be remainder. Remainder is 1. So 1 is going to be answer. For example, if it would be 40 mod, let's say 31. So what will be the answer? 40 is greater than 31. So we will do 40 divided by 31 raised to power 1, 31. What is the remainder? 9. So 9 is the answer. So this is the way how we solve modulus. Now, if coming back to this question, so let's say here what will happen? Both the parties, sender and receiver, they will pre-share this particular you can say random number generator. Other than that, A is fixed, which is multiplier. For example, A is 2. For example, C increment is also fixed, which is, let's say, 3. And for example, XI, which is called seed, initial seed, and let's say initial seed is 4, for example. This is basically the first time values, and after that, this random number generator will work on its own. For example, how we can generate first random number? XI, if I plus 1 is equal to 2 multiply XI, which is 4, plus C is 3, mod, for example, M is equal to, let's take 13. Now, 8 plus 3 mod 13, it's going to be 11 mod 13. So answer is going to be 11, because 11 is less than 13. Now, this is the first random number. Random number, you can say first key for encryption. Next time, for the next iteration, over, we will calculate xi plus 2. Now formula will be a xi plus 1, the previous value, plus c mod m. Everything else will remain same beside the output. Now this is random number 1 or the key number 1. For the key number 2, it's gonna be a is again 2, xi plus 1. The previous random number, previous key will become the next xi plus 1, the seed. 11 plus 3 mod 13. So now 22 plus 3 mod 13 it will be 25 mod 13, bigger than 13. So 25 by 13, 1, 13, and the answer is gonna be 12. So 12 is the next random number. Then we will use this one, and this process will keep on repeating. This process or this particular method is called linear congruential method, and this is basically one of the method of pseudo random number generator. How two parties, they can generate same random numbers. So sender and receiver both will have the same generator, same formula, same seed initially, and then they will keep on generating same keys again and again. Next is basically the one-time pad or one-time pad, one-time password, whatever you want to name it. One-time pad is basically it's kind of a true random number. In fact, one party actually generate one-time pad. So one-time pad, OTP, or one-time pad or one-time password, one-time pad, in fact, please remember one thing: it is theoretically impossible to crack OTP, because there is no pattern, nothing like that. It is 100% or true random. Like for example, and again, sender sends OTP each time to receiver. So each time receiver will receive this OTP. So let's say this is sender. So sender wants to send a message. So sender wants to send this particular message to receiver. So before sender send the message, sender has to send the private key, like OTP, one-time pad to receiver. And then receiver will actually, the same process, use the same algorithm, and then it will try encrypt and decrypt the data. Example of OTP is basically the Soviet spies during the Cold War. Moscow, Russia, what they used to do, Moscow, they actually print out 2 copies of one-time password, one-time pad. They actually print out 2 copies. One copy took spy, if spy is in US or some other country, he took his one OTP book, and one copy remained in Moscow. So spy, what he used to do, he or she used each OTP book has 365 pages. 1 page for 1 day. So he or she uses 1 page. Let's say, for example, he want to send something on January 2nd. He will use page number 2, use that OTP password code and encrypt the data, send it to Moscow. And then they have the same book. They will use, because the data is sent on January 2, they will use the page number 2 and decrypt the data. This was basically how old encryption, these stuff actually works out. But that's the best example of one-time password where each page is truly random, no relationship with the other pages. The last item or last scheme to generate the key stream is hash function based. Hash function based key generation. So initially when we started using hash functions to generate a key, so there was a defective scheme, a defective scheme, and that defective scheme is like, for example, this is a key. Now 2 parties, they have the same key at start. They have the same key. Beside the key, they also share a hash algorithm. Hash algorithm, for example, SHA-1 or any kind of hash algorithm. So what will happen in the defective scheme? Key, firstly, user will, both sender and receiver, they will use the same key, and this is the first time when they start communication, they will pre-share this only one key. After that, this process will repeat itself. You will get a hash value after you calculate we just calculated the hash value for the key. So we got a hash. This hash value will be your first random number 1, or you can say key 1. This is key number 1. In order to get the second key for second iteration, we'll use this particular hash value or function and calculate the hash algorithm again. Hash of the hash value. Okay, so you will get the another hash value, or you can say key 2. Next time, for next iteration, key 2, which is a hash value of a hash value, again we will calculate a hash value of that. This process will keep on repeating, and then we will each time both parties can generate the same random number, same key in fact. But this was a defected scheme. We actually improved this scheme by using this, like same process but improved scheme is, again we have a key. For the first time, what we will do is we will calculate a hash by using hash algorithm. So we got a hash value. This is your first random number or first key. This is key number 1, key 1. In order to calculate the key number 2, what we will do is we'll use this key 1 or hash value. Okay, then we will add this hash value with this key. Each time key will be added, key, and this is key 1 or hash value, key 1, and then calculate the hash value of that. Next time, once you calculate that, you will get key 2. Next time, what we will do is we will use key 2 and that particular secret key, calculate the hash. Key, calculate the hash. Again, the process will, we will repeat the process again and again. So bottom line is that you need to remember, in hash function, if we use key plus previous hash, then we can actually have more stable keys. We can generate more stable keys. Key plus previous hash and calculate a hash for that each time. This is basically the most stable addition of that. Last thing for it's the some file encryption software. As I mentioned earlier, file encryption software. So Microsoft Windows, as I mentioned earlier, in Microsoft Windows, they have introduced a feature called BitLocker, and BitLocker specifically use AES for encryption. This is basically a file-based encryption. You can encrypt your whole hard drive. You can encrypt your folders, files. I'll show you guys in our lab. I'll show you guys how we can encrypt the folders and all. Other than that, Apple, it has their own folder. It has their own algorithm. Apple operating system, they have their own algorithm to encrypt the data. I forgot exactly what they call it, but I'll figure it out. There are some other independent application. For example, one is PGP, Pretty Good Privacy. Pretty Good Privacy. You might have used this particular software, or you might have used WinRAR. It's basically for zipping, zip, PKZip, etc. These are basically some encryption software that are used to encrypt the data and all. Another very important point that I think we already talked about, if you want to erase a plain document, erasing a file, so it's recommended to 3 times you need to overwrite the file before you finally delete the file. So if you really want to get rid of a file, you need to overwrite the file 3 times, like save by putting something else on that particular file, and then you can delete the file. Then this particular file cannot be recovered in true sense. Application of this symmetric, we use symmetric encryption in even in DVD players. So DVD players, Blu-ray players, they actually use this symmetric encryption. If you have a DVD or a Blu-ray, all the data is basically encrypted in DVD or Blu-ray. If you want to decrypt that particular data, you need to actually we need to insert the DVD in DVD player. So DVD player, it has its own player key, DVD player key, and that player key can decrypt the data written onto DVD. So DVD, if you have a DVD, in DVD data is compressed and encrypted. If you want to watch the data on DVD, you need to actually decrypt the data. How we can decrypt the data? By using player key. the DVD player key, in fact. And of course, we have used in DVD, we use the same key to encrypt the data. So same key is used to encrypt the data, okay? And same key is required in order to decrypt the data. Same is the case with Blu-ray. In Blu-ray, we need a Blu-ray player to decrypt the data, because Blu-ray player's key has been used to encrypt the data of the disk. So that's it for chapter 6. If there is any questions, please let me know.